Hello everyone, in this video we will discuss the hydrogen couple. We will proceed with our material in electrochemistry and we will discuss today in this video the hydrogen couple. So as a quick recall, in the previous video we deduced what oxidation means. It's the process where uh, elements lose electrons. Reduction is the process where elements gain electrons. The oxidizing agent is the one that undergoes reduction. The reducing agent is the element that undergoes oxidation. And we talked about why it's vice versa. The oxidizing agent is reduction and the reducing agent is oxidation. Usually students makes mistakes concerning this, so they would say, which is wrong, the oxidizing agent is the element that undergoes oxidation. It's wrong. The oxidizing agent is the one that undergoes reduction, okay, and here the reducing agent, the one that undergoes oxidation. Please review the previous video if you want more clear answers concerning that. We have the redox couples. We talked about the redox couples, how to write the redox couples, and we finished our discussion with the electrochemical axis. Now we will move to this video to talk about what we will discuss in this video. We will interpret actually the action of acids on a metal. Today, in the last video we talked about the metals, purely metals. We have zinc, copper, we mix zinc with copper sulfate, we mix copper with Ag plus ions. Now we will talk about what we will have if we mix acids with a metal. And we will show and we will prove the existence of a new couple, which is not metal, it's hydrogen couple. Hydrogen couple. We will talk about it later on in this video. So in a brief experiment, we have three beakers. This is one, this is two, and this is three. So we add iron to hydrochloric acid, HCl. We add iron Fe, iron as a metal, iron strip to HCl in beaker 1. In beaker 2, we added Zn to HCl. And in beaker 3, we added copper to HCl. Here we have to mention that the HCl is diluted. We're working with diluted acid. In the first one, we had a reaction. There was a reaction. And in the second test tube, the one with Zn and HCl, we had also a reaction. Here, no reaction. No reaction. Now, how we were able to recognize that there was a reaction? Through this, I want you to watch the video. So here we have hydrochloric acid inside the beaker. Whenever we're just adding, here we are adding Fe iron, look, the iron starts to disappear. The iron starts to disappear. And we have liberation of gas. As you can see the bubbles here, we have the bubbles here and the liberation of gas. And as well, it's exothermic. So what I'm interested about is that we have bubbles, iron Fe disappeared, and it's exothermic. Okay, we have heat. This happens when we added Fe to HCl. And again, this happens also when we added Zn to HCl. So Fe, in this case, Fe is becoming Fe2 plus. And Zn is becoming Zn2 plus. Because it disappeared. It dissociates with the reaction. It dissociates with the solution. Now here we don't have a reaction. It's interesting. It's interesting that we don't have reaction with copper. But And we proceed testing the gas, the bubbles that we had, and it detonates when a flame gets near to it. Okay, this means that we have hydrogen gas, H2. Hydrogen gas, hydrogen gas. We have them. We have these hydrogen gas inside the as a bubbles coming out from the solution. Okay, so a gas formed, a slight detonation is produced when a flame is brought near to the tip of each beaker. This means that we have a hydrogen gas. Okay, it's hydrogen gas. So I want just to make a brief introduction concerning acids. When we have acids, you can see that some writes acids as H3O+, which are the hydronium ions. Well, HCl actually it's H plus Cl minus, and H3O plus actually it's H2O plus H plus. So if I said H3O plus, as if I'm saying H plus ions. So here inside the reaction, I'm adding Fe to H plus ions. As I've mentioned before, that Cl minus is a spectator ion. Spectator ion, it's involved inside the reaction, but I'm not interested studying a spectator ion. Okay? So here we have Fe is added to HCl, means Fe is added to H plus, we're getting Fe2 plus, and the liberation of hydrogen gas. We're getting hydrogen gas. Okay? So again, the reaction is, let's talk about the Fe. We added Fe plus H plus, we're getting Fe2 plus H2, which is the hydrogen gas. Here the reaction needs to be in equilibrium, so we add here 2 hydrogen. So 1 mole of iron reacts with 2 mole of hydrogen ions. Okay, this is the reaction. Well, it's interesting because now hydrogen is being involved inside the reaction. Hydrogen is being involved. It's not a metal. And that occurs also to Zn. When we added Zn plus 2 hydrogen plus, it gives us Zn2 plus H2. Now here, the H plus ions has oxidized Fe, okay? Has oxidized Fe and turned it into Fe2 plus. Let's talk about this example, about the example of iron, and let's talk about the half reactions occurring inside the solution. So Fe is becoming Fe2 plus 2 electrons, and here we have 2H plus 2 electrons is becoming H2. Okay, this is what oxidation, half reaction, and this is reduction, half reaction, right? In this case, Fe is the reducing agent and H plus is the oxidizing agent. So whenever we added H plus, we added an acid which H plus ions were able to oxidize, were able to enable iron to undergo oxidation. So it was Fe and it became Fe2 plus. And we can say it in another way, that metal Fe has reduced the H plus ions into H2, hydrogen gas. So we can put this into category that this reaction is oxidation reduction reaction. We have a transfer of electrons, okay, from iron, which loses electrons, undergoes oxidation half reaction, to hydrogen ions, which gain 2 electrons to become H2. Okay, whereas the Fe, the iron, was the reducing agent, and the H plus hydronium ions were the oxidizing agents. So the reduction between H plus ion and metals, Fe and Zn, these two metals, is an oxidation reduction reaction which implies an electron transfer between the reactants. Okay? Clear? So the reactions between acidic solutions and metals. So the reaction between H plus ions of a dilute solution of an acid and some metals is an oxidation reduction reaction which implies an electron transfer between the reactants. Okay? In the oxidation reduction reaction between a dilute solution of acid and some metals, the H plus is the oxidizing agent, and we can say that it undergoes reduction, okay, and the metal was the reducing agent, or it undergoes oxidation, okay. But that's not always the case. We just need to stress on some, okay, not always the case. We will see. So as to sum up our ideas here, the reaction, the half reaction that H plus did, it was H plus to H plus 2 electrons. It brings us to H2. If we want to write the redox couple here, we can say that it's H plus H2. This is the redox couple of hydrogen. This is the oxidizing agent, and this is the reducing agent. Okay, we're good. So it's an oxidation reduction reaction where electron is being transferred between the reactants. H plus is the oxidizing agent, and Zn and Fe in our case was the reducing agent. Now we have to put the position of the hydrogen couple in the electrochemical axis. So if you still remember that, we have the first reaction was Fe plus H plus 2H plus, just 2H plus, gives us Fe2 plus H2. In the second one, we have Zn plus 2H plus, gives us Zn2 plus H2. Now the third reaction, why I told you that hydrogen H plus is not always the case. It doesn't act always as an oxidizing agent with metals. We will see that because Cu plus 2H plus, we have no reaction. We have no reaction. This means that these two elements don't work together if the hydrogen was an ion and the copper was a metal. So if we want to interpret this, hydrogen is a stronger oxidizing agent than Fe2 plus and Zn2 plus. Hydrogen H plus, when I say hydrogen means I mean H plus. H plus is a stronger oxidizing agent than Fe2 plus and Zn2 plus. Whereas hydrogen ion H plus is a weaker oxidizing agent than Cu2 plus ion, because it has not oxidized Cu. It didn't oxidize Cu. We don't have a reaction here. If you have any misconception concerning this, I advise you to go to the previous video where we talked about the electrochemical classification. Okay? So if I want to place hydrogen, okay, based on these previous reactions, okay, let me just again write the reactions. Okay, so we have Cu plus H plus 2H plus, no reaction, right? We have Fe, no, Fe plus 2H plus, this is nothing, okay? Fe plus 2H plus, we have, it gives us to H2 plus Fe2 plus, and we have Zn plus 2H plus, it gives us H2 again plus Zn2 plus, okay? Now we want to place hydrogen couples. Hydrogen couples, as I've mentioned, hydrogen couples is H plus H2 in these metals. If you still remember these metals, we talked about these metals in the previous video, and I advise you also to revise the electrochemical axis. Okay, so we have to start with Ag plus Ag, okay, Cu2 plus Cu, and Fe2 plus Fe, and Zn2 plus Zn. Now, copper was, as you may notice, that H plus has a weaker oxidizing power than Cu2 plus. Okay, then H plus should be below, because you know this is the oxidizing power increases, should be below, okay, Cu2 plus, because it has a lower oxidizing power than Cu2 plus, and that's because the clue is because we don't have a reaction. Now H plus has a stronger oxidizing power than Fe2 plus, because we have a reaction here, and as we recall back that in the electrochemical axis, the reaction is spontaneous when the stronger oxidizing power reacts with the stronger reducing power. Yeah. Okay. So here, because of the reaction, so H plus has a stronger oxidizing power than Fe2 plus. We compare oxidizing agents here. And okay, this we're comparing here oxidizing power. And also H plus has a greater oxidizing power than Zn2 plus. Now, where is the place of H plus? Based on these conclusions, H plus is here. It has lower oxidizing power than Cu2 plus and a higher oxidizing power than Fe2 plus, so it should be here. So here we put an arrow, and here we have H plus and H2, and this is the place of the hydrogen couple inside the electrochemical axis. And to make the reaction here spontaneous, by going to the reaction here, Cu plus 2H plus, we got no reaction. To make it spontaneous, we need to go back to the gamma rule, where Cu2 plus reacts with H2 to gives us H plus and Cu. Okay, and also silver can react with H2 to gives us H plus and Ag here. So that's it for this video. We talked about the hydrogen couple. It's a small video. I could have merged this video with the previous one, but the previous one will be so large. So I decided to break them down to talk about the hydrogen couple. And we in this video we learned that how we can interpret the reaction of metals with acids, and when we mean by acid is H+, and we were able to place the hydrogen couple inside the electrochemical axis. So the reaction between the hydrogen, H+ ions, and metal is an oxidation reduction reaction, or in the case we can have a reaction between Cu2+ and H2 to give us H+ and Cu, which is also an oxidation reduction reaction. Hope that you enjoyed the video. Goodbye.